How do you safely handle interrupts in embedded C programming? Imagine your microcontroller is like a busy worker handling many tasks. Suddenly, an urgent event happens, like a button press or a timer overflow. How do you make sure it responds correctly without messing up what it was doing? That's where handling interrupts safely comes into play. First, understand that interrupts are signals that tell the microcontroller to pause what it's doing and run a special function called an interrupt service routine, or ISR. The ISR quickly addresses the event, then the main program continues. To do this safely, keep ISRs short and simple. Only include essential tasks, like setting a flag or updating a variable. Avoid complex calculations or loops inside the ISR because they can slow down or block other interrupts. Next, you need to control when interrupts are allowed. Use functions or processor instructions to enable interrupts when your system is ready to handle them. When you're in a critical section of code, disable interrupts temporarily. This prevents nested interrupts from causing data corruption or timing issues. For example, on microcontrollers based on ARM Cortex-M processors, you can disable interrupts by setting the primask register bit and re-enable them by clearing it. Shared data between the main program and ISRs needs special care. Mark shared variables as volatile so the compiler doesn't optimize them away. Protect these variables by disabling interrupts briefly when you access them in the main code. This prevents race conditions where both the main program and ISR try to change the same data at the same time. Always clear the interrupt flags inside the ISR. These flags indicate that an event has occurred. If you forget to clear them, the ISR might run repeatedly, causing your system to freeze. Prioritize your interrupts if your microcontroller supports it. Higher priority interrupts can preempt lower ones, ensuring critical events are handled first. Use edge-triggered interrupts when possible. These activate on a signal transition, like a rising or falling edge, which reduces repeated triggers. Level-triggered interrupts can cause multiple calls if the signal stays active. Offload heavy processing from the ISR to the main program by setting flags or adding data to queues. This keeps ISRs quick and responsive. Finally, always check your microcontroller's datasheet and reference manual. They provide specific instructions on how to enable, disable, and declare ISRs properly. Some compilers requiring special keywords or pragmas for defining ISRs. For example, in a system controlling LEDs and switches, an external interrupt triggered by a switch press can run an ISR that sets a flag. The main loop then checks this flag and updates the LEDs accordingly. This way, the ISR stays quick, and the main program handles the heavier tasks. By following these steps, you can handle interrupts safely in embedded C. This keeps your system stable, your data safe, and your responses timely, making your embedded projects reliable and efficient.